Hi everybody. Um, I'd like to record this video as a companion of my latest blog article, Simple over Easy for Operations. If you want to read this article before watching this video, it will help you to understand what I'm talking about. Long story short, I have created a workflow for operations. It is written from scratch, and in this blog article, I go in the details of what are the challenges of creating a workflow engine from scratch. And I will use now the REPL to show the first steps. In the first part of this video, I plan a second part where I show the more difficult challenges and how I solve them. There are mainstream solutions like temporal and restate to implement workflows. AWS has step functions, but there you have a DSL, is not with coding. And I think these solutions are easy, but they are not simple too. So it's easy to start. They support all the languages, but I think for the purpose of workflows for orchestration, I don't think we need so much flexibility like a generic workflow engine. So BigConfig is specialized for operations, and in the blog article I go in the details of what are these facilities that you can leverage. So let's start with the basic. So if we have a workflow engine in mind, we can start thinking, how can we implement this? Then I will introduce the debug macro, the workflow constructor, and the spy function so that I can show you a full cycle of the working flow. So here, let's start from scratch. Let's copy this, paste it here. Okay, now we have this, we remove everything, we pretend we don't have anything. So we have debug, that is the macro that I use to write code in Clojure when I create workflows. And then we can start with the thread first, okay? So what is a workflow? We can assume that there is a data structure, a map, and then we want to pass this data structure to functions, function 1 and function 2. And these functions are doing the side effects. So in this way, we can execute Terraform, Ansible, whatever CLI tool, or even writing code directly talking with APIs ourselves. Okay, so to have this working, we need to define a let in Clojure, and this let is gonna define function 1, and this function is just taking the options and return the options. And then we double function 2, and then we save. Okay. Okay, so now we have the first workflow for us that we can execute, and tab values is populated by the macro. It means that we didn't spy any value, so it's an empty list. We start with a map, and this map doesn't do anything special. So let's start making changes to the map and tapping something. So in this case, we would do tap. Then we will say we are inside function one, and we want to save the options, okay? And then at the same time, we say, you know what, I'm gonna change the option, no? I'm gonna change the value a to function one, okay? And the same thing I will do here. So I will tap, I will do function two, I will pass option, and here I will associate to option. So now R is pointing to function one. So this R and function one, these are keyword enclosure. And we start sending at the beginning a state that is start, okay? Okay, so if we do this, what it will happen now is that if we evaluate, here there is a typo, after we do this workflow, the last value of a is function 2 as expected. But the interesting thing is that if we look at the top values are not a equal to function 2, but they are just frozen in time. And this is one of the feature of closure that I think is very important in programming, but also in the creation of workflows for operations. So you have snapshots of the state. So you can really spy the state is an immutable data structure. We structure sharing. So it means that whenever I tap the value of option, if option changes over time, it doesn't change my copy. And this is very useful for developing workflows. Now, the challenge here is that the workflow with just the thread first macro is not flexible enough, because if you have a workflow, probably you want to execute all the steps with the happy path, but eventually if there is an error, you want to skip the rest and go immediately to the cleanup step. You don't want to continue the workflow, right? So branching is not possible like this. So if we go back to the plan, we introduce the constructor workflow, and now we show how we can handle this, and we will show also how to define the spy function. Okay, so here we can delete this part, right? Actually, we don't delete it, but we just augment. So in closure, we can comment an expression like this. So this will not execute it anymore. And we define a new function called workflow. And this workflow is actually defined like this. Okay. So we can read the manual. It takes a first step, last step, while function, next function. Okay, let's start with the first step, that is start. And so these are the keywords that are associated with the function so that we can implement branching. So the first step to be executed is start with the equivalent function associated. And then we pass a while function. And this while function is taking the step and the step function, but in this case, we don't use sub workflows, so we don't need to pass the step function to a sub workflow, so we can ignore the value. And then with a case expression, we check the step, and then we say, look, if it is start, then execute core, okay. So it means take the option, this is an anonymous function, take the option, make it okay, in every step needs to return, like in Go, structure. So two fields in this case, an integer and a string, if there is an error, like a shell program. So we say this, and then we go to the next step, that is F1. Then in F1, we say, okay, now call F1 the function. Maybe here we should call it fn1. And then we call fn2, and then we say fn2, and we say function2, and then we go to end, okay? And in end, we call identity, because actually it's a special step, so it should not change the return. The exit value 0 or 1, it should not change it. It should just clean up resources in this step. But in this case, we can just do identity. So it means that the option receive is going to be sent like it is. And to invoke this, we need to do workflow. And then we pass the step function. And then we pass the start. Okay. So let's see if it works. So the BigConfig exit is 0, BigConfig error is nil. This has been populated by core OK. And we have some tab values that are generated by these guys. So we can remove them, run again. So the tab values is now end. The value is still fn2. And what we can do now, we can implement a spy function. And the spy function is a step function with this signature. So it takes the function. Def will be step start, step fn1, step fs2, and identity. Then it will take the step and the options, right? So if we take this, then we can tap the step and the option, and then we can invoke as expected. So this is the pattern of the middleware, right? So if we run, here we can observe what's going on. So the workflow is executed exactly as before, but we have a nice trace that says start, receive the object, the map empty. Then function1 receive an object with error nil, exit 0. Function2 the same, and then end the same. So you can really tap and get exactly the trace of all the state in your workflow very, very easily. Okay, so let's see if I have forgot anything. Okay, so we have introduced the thread first macro, that is like the naive workflow, then the debug macro that enables us with a language like Clojure to have more powerful developer tools. We introduced the constructor workflow, arrow workflow, and then we show how the spy can be implemented. And the last thing, we could throw an exception here. So let's say we go here and we do throw, and I think the syntax is exception dot something went wrong. Okay, so if we execute this, as you can see, the workflow capture the error. By default, if a function throws an exception, it will convert it to exit 1 plus the error value as a string plus the stack trace. And the interesting thing is that we can inspect the tab values outside And this is very convenient when there is an error that blocks even the execution um, of the code. So it's more severe. So actually, you don't have the map that is returned, but it's something going very wrong. But still, you have the tab values because of this macro. So you can still check, and here you can see what happened. So we have the exception thrown at fn1, okay? So start with the option that is empty, then f1 receives from start exit 0 nil, and then we short circuit to end, okay? So we skip fn2 because there is an exception and doesn't make sense to continue. So the default wiring of the workflow is to go to the end step automatically if there is an error. And this is actually containing the well-known qualified keywords for error, exit, and stack trace. What else? Yeah, so going back to workflow, this is the manual. There is first step, last step, the where function. We didn't talk about the next function. That is when you need to handle more complex um, branching. For example, here, this is the lock example for Terraform. So you can create a client-side lock using Git tags. And here you have the next function that depends on success or failure of the lock. So if there is, so here there is choice, success, failure, two different steps. Okay, so this was the video companion of the article where I wanted to show a different way of working. It's not easy because, of course, Clojure is a niche language, but it's very powerful. And so, from my point of view, with this, my experience with operation is that if you follow the easy path, you use tools that are familiar, but probably they are not really the right tool. And if you're not aware that it's possible to work differently, that there is a simpler way to do things, I think you miss an opportunity. And from my point of view, learning Clojure just for doing operation is more than reasonable. It's a very powerful language. It has all the capabilities that you need, like it's dynamic. He has the macro system, the data structure are immutable. There is the REPL, you can develop interactively. And this workflow, they need to render template files, okay, configuration files. So it means that if you do it interactively, it's way better than using a CLI tool like Helm, where you compile, then you have a syntax error. Good luck in debugging it. Yeah, I think if you do it in Clojure, you see the debug macro, you can spy anything anywhere with a dynamic language. And there are many, many other reasons. So that's why I think I try to explain in this article why we should choose simple over easy. And Clojure is a safe bet. Thank you, everybody.